let's talk about consistent hashing. Um, it's not to design a hashing system like consistent hashing. It's just want to explain how it works and why we need it. So today's topic is consistent hashing. Firstly, it's very popular for like even big companies or very mature systems to use consistent hashing, like DynamoDB, even Netflix for their CDN, etc. So firstly, let's talk about why we need um, consistent hashing. Long story short, so we used to, for example, if we only have a limited size of data, we can just store all the data in a single node, right? Either like cache data or like, I don't know, the other like mostly cache data. I would say it's quite um, a popular, but maybe we have other usage. Yeah, so like KV store, etc. So a single node may hold all the data, or we can vertically scale the single node. However, at some stage, the single node just cannot hold all the data. So we have to like scale, or we have to shard. So now we need, let's say we need to shard the system, and we need to hash the hashing the key to different shards for the data, right? So there are like different hashing algorithms here. For example, the static hashing algorithm, the mod. So for example, if we have like 4 servers and we have a key like hash key, the value may be like 5, then 5 mod by 4, that goes to 1, right? So that key, the value of this key will be stored in the server 1. So that's like how the static hashing or the mod algorithm works. However, you can see the issue here. So firstly, it's definitely like hotshot or hotspot issue. So we may have like a lot of like users, or I don't know how we decide the key. We may have a lot of records or data in a single shard. So again, we will met like, okay, a single node cannot hold the data, while we may have other shards, they're just empty, or like maybe less the utilization. That's not ideal. The second problem is if we based on the number of the servers to do the hashing, it's really like for the rehashing, it'll be very painful and time consuming and very operational. If you want to, let's say, adding or like removing a single server, a single pod, single node. For example, we may remove one pod. So we used to have 4 servers, now let's say we have 3. And then for the here the key equals 5. Oh, sorry, the hashing value. Okay, so the hashing value of the key, for example, if we still use we still get 5, and then 5, now we should mod 3, right? Because we only have 3 servers, that give us 2, which means the value will go to server 2 right now. So there will be a lot of data moving, a lot of like rehashing, and it's quite painful. That's why I would say like the static hashing algorithm will not work, or like it'll be like not ideal solution for us. And then that's why we need to use the consistent hashing. And now we talk about what, like what is consistent hashing. So on a very high level, imagine we have a ring here, and that's all the key space. So we start with here, like let's say the key value, sorry, the hashing value of the key will be 0. And then it will, clockwise, it will come to 1023. So then like our key space here will be from 0 to 1023. So we totally will have like 1024 key space, right? Or keys. Okay, so that's what we have for the ring. Oh, what I did do? Okay. And then imagine we may have like 4 servers. So let's put the 4 servers here. So we have one here. It's server 0. We have one here. Let's say server 1. And we have one here. That's like server 3. Oh, server 2, sorry, server 2. And finally, one here. Oh, yeah. That'll be server 3. Okay, so we have like 4 servers. And then for any like the hash value for any key, if for example it's mapped here, the hash key, the value is here, then which server we should store this value based on the hashing of the key? It will be, if we do a clockwise check, it will server 0, right? So for this, the server 0 will store that data. That's like quite straightforward. So we have like 4 servers. We have a ring about the key space, and we can easily get the which server we want to store, right, for that data. However, if you see here, it will only resolve one issue. So remember, we have 2 issues: hotspot issue in a single shard and rehashing. So if we want to remove one server, for example S1 for this case, so S1, yeah, so we want to remove that, and then all the value, all the like data we stored here, like they used to be stored in S1 for data here, right? We will move them to S2, and it will only impact the 1/4 of the ring, just this part. So we resolved the rehashing issue, right? We do not need to rehash most of the data. We just need to rehash 1/4 of the data. We only need to move this part of the keys. So we fixed the second problem. But for the first problem, the hotspot issue, if we remove server 1, you can see clearly that half of the data will be stored on server 2, right? So we have a hot server here, like server 2, and it's not well balanced. That's not how we design hashing system or the sharding system. So how to resolve this? So how to resolve the, okay, this fixed the second problem, rehashing, right? But then how to resolve the first problem, which is the hotspot? It's the virtual node. What does that mean? So we still have the same hashing ring here. We still have these like 4 servers. S0, oh, so we have S0 here. We have S1 here. lowercase s, yes. And we will have the s2 here. Oh, yeah. Oh, I don't know what happened. Delete it, and then, yes. Stop here. Okay, so here will be s2, and then here s3. So we still have these 4 physical part, right? Or nodes. They are like S0, S1, S2, S3. And then since our key space is 1024, we may have 1024 virtual node. That's maybe too much. Let's say we have, for the virtual nodes, let's say we have maybe 32 virtual nodes. And then for V0 to V7, that will be on the server 0. Similarly, V8 to V15 will be server 1, etc. So then we will distribute the virtual nodes evenly on the ring. What that means is like, okay, we have here maybe like V0, 1. That's like the first V00. That's like the first virtual, that's the virtual node V0 on the first physical node. And then we may have another virtual node here. We say this one will be V1. So we will not have S3, we will have not S0, we will not have the physical node, we will only have the virtual node. And then we may have here another virtual node, V0, 7, etc. So you can see they are all the like they are all on the physical S0, but they are distributed like evenly on the ring, right? So similarly for other virtual nodes. Then the more virtual nodes, the more like split for the ring, and the more I would say distributed of the system, or evenly distributed. So that should fix the first problem, like hotspot. We can just add more virtual nodes, but not too much though, because that will add more operational cost to the team and also to the system. So okay, now we have 32 virtual nodes. How do we know which key is on which virtual node? Similarly, we'll have maybe have a key here. The hash value of the key comes here, and then similarly clockwise we got V001. Oh, sorry, V000, right? V0 hyphen like 0, so that's like on the S0. So now we know this virtual node. If this is a very large system, it's like quite it's quite time consuming for each hash key to check the virtual node. To fix that, we may use a binary tree. So instead of like linearly check all the virtual nodes, on the ring to get like which virtual node we have to locate that hash key, and then we can just do a binary tree search that will save the time complexity from O n to O log n, right? That's one optimization we can do. The other thing is how to map so this is the key to the virtual node. Then the second will be how to map the virtual node to the physical node. For that, we will use the service discovery. So we will have a service. And then at the back of the service, we'll have the ZoneKeeper. And then we will store all the information in the ZoneKeeper for the mapping, virtual node to physical node, IP address of the physical node, etc. So then the client, or here I would say any service who will using our either key value store or like how to they want to check the virtual node, they can just query our service discovery and then get the data. Get the mapping like virtual node to physical node. And when you design how many virtual nodes we need for a certain amount of physical node, we may do some like data estimation, pre-calculation, maybe some like very deep diving to make sure the number of the virtual nodes quite makes sense for even like 5x of the key increase. So we don't need to keep changing the virtual number of the virtual nodes in like 1 year or 2 years. So that should be it. Thanks for watching.